So continuing on from where we left off, the angular momentum of the electron in the hydrogen atom is quantized according to Bohr's model. That lets us, we can solve for what are the, what's the velocity of the electron. So we can rearrange this equation we have over here and take the velocity is going to be equal to nh bar over the mass of the electron times r. And we can, again, go back to our, we can plug that into this equation up here. So now we know V, and we can make that substitution. Let me get my, there we go, got the zoom right again. And so we can say E squared over 4 pi epsilon naught r squared is equal to the mass of electron times the velocity, which is nh bar over mer, divided by r. And so we can solve this for r. And what we get is that r is equal to 4 pi epsilon naught h bar squared n squared divided by me e squared. And this n is still here, right? And so what this says is that the orbits are quantized, meaning that the electron isn't free to orbit at whatever distance it wants. It has to go at specific distances from the nucleus, because there's this integer that shows up, right? This n squared. So n can only be equal to 1, 2, 3, 4. You can't have a half or anything like that. And so according to Bohr's model, the electron can only go at specific distances. And so if we kind of, draw a picture of that, we can say, have our electron, this would be, represented by n equals 1. And maybe you've seen this picture before, n equals 2. But the electron can't be in between, in some orbit in between these distances. Okay, and so Bohr actually still has something named after him from this. If we set n equal to 1, r is given the symbol a naught. If we plug in n equals 1 and plug in all these units here, this is equal to 5.29 times 10 to the minus 11 meters. And this is known still as the Bohr radius. So in this imaginary, model that isn't correct, this is where an electron would be orbiting the nucleus if it was in fact this sort of orbiting. This is not correct. This is just as a reminder. But this is still getting at these ideas of quantization of angular momentum and distances from the nucleus. So the last thing we want to find out that's related to this is energies. And that's what we'll look at in the next video.